I wanted to make a brief video today about a problem that you may have if you have a mobile unit set up in your vehicle that you may not even know that you have. I know that I had struggled with this on UHF, VHF, and HF in my pickup truck. And pardon the background noise if you hear lawn mowers and weed eaters in the background. It's the neighbors getting the yard cut. But anyway, if you look right here, let me show you this current setup. We have a mag mount antenna with a telescopic whip for HF that is fully extended. It's 18.4 feet long, so it should be more than sufficient to cover the 20-meter band for HF. And the mag mount that I'm using here is just a standard mag mount. I've got two different ones that I'm going to show you the situation that you may have, and they both do the same thing. So we're going to swap around here in a minute, but let's continue. So you got a mag mount on the roof of your vehicle with some type of a antenna on top. Well, with this, with the antenna fully extended, I can only get somewhere close to resonance on 14.14 megahertz, and that is with a SWR of 1.5. Now you may look at that and think that that's good, but watch what happens when I move this coax cable that's attached to the mag mount. Let's see here. It'll start moving. Oh, see that? There's something going on here with the antenna. It's not properly working like it should. The resonance changes by just moving the cable, and it should not do that. So as you see, you move it just a little bit, it can go up to 1.7. So something's wrong here, and you might find this with many antennas. Some vendors will tell you to mount the antenna at a particular point, and you know, what they're doing is they're masking the real problem. The problem that is that it's not stable, the hookup. So let's look at what takes care of this. So again, we're at 1.5 for a SWR, and it's at 14.114 megahertz with the whip fully extended. Now stand by and I'm going to show you what the fix is for this. Let's talk about first what the problem is. We see that it's moving anytime you move the coax cable, which is indicative of something going on. And what's going on is that there are common mode currents on that cable. That's problem number one. So what I found to resolve that was on this mag mount, I put a ferrite core which took care of the common mode currents. Now in your vehicle you may be able to put it on the radio end. I had to put it on the mag mount end in my situation because it worked better. It took care of the problem better than using a ferrite core on the radio end. So now let's look at let's hook this up and then see what changes happen with the SWR and the length of the antenna. So be right back. Okay, now our current setup is we have the mag mount with a ferrite core at the base of the mag mount, or at the base of the antenna at the mag mount end. It's still fully extended, and what we have now is we have a frequency that's resonant, it's on the high side, 14.441 megahertz. So this is actually higher than the previous one that we had, and the antenna is still fully extended. So what's the problem here? Well, first off, let's look at the problem one problem that we had solved, and it's the fact that with the movement of the coax, we previously had a change in SWR. So now we can move coax, we can do whatever we want to on the truck. It doesn't matter. The SWR is stable. But even with an 18-foot antenna, we can't get a resonant frequency less than 14.4. So what is the solution to this? Well, a key indicator is in the Smith chart up here. You see that we're looks like we're a bit on the inductive side. So what we need is capacitance added so that it will bring things back down where they need to be and improve our SWR from a 1.5 to something better. So stand by and I'm going to show you what I did to well, I'm going to give you show you what the problem is, and then you can decide what to do to best fit your situation and resolve the problem. So stand by and we'll show you it. Okay, now look at where we are. The resonant frequency has shifted, and let's see what it has shifted to, and then I'll show you what was the solution to this. So now we have a resonant frequency at 13.31 megahertz. So we can shorten the antenna to take care of this. So what did I do? What did I do to take care of the problem that we had? Well, we needed more capacitive coupling to the body of the vehicle. So let me show you what I did. And then this is not a permanent situation, but this will get you through a situation if you're parking, doing mobile contact. So here's what I did. All it takes is a little bit of aluminum foil laid in contact with the vehicle and then tied to the ground of the mag mount. That's all it takes, and that brought it down to 13.131. Now let's see if we can get that closer to 14.250. We're going to lower the antenna a bit here. There, that's one complete section. So let's see where we are now. Oh, it's moved significantly. We're now at 14.376. So we went a little bit too far, but that's usable right there. So let's go back up. And now we are at, let's see where we're resonant at. 14.14. That's perfectly acceptable. And look at the SWR. The SWR, instead of being 1.5, it's now 1.2. So if you wanted to improve on this, you could use more foil or some other method to increase the capacitive coupling between the mag mount and the body of the vehicle. So what is this bias? Well, it gets us on frequency, it lowers SWR. We know that a better SWR reading puts more power to the antenna, and the antenna radiates more. So we know that. So there's the opportunity and the potential to get more gain. Now I wish I could remember the call sign of the guy that I was talking to, but it was a guy who was working HF portable because he lived in an apartment and could not have an antenna where he lived. So he had a vehicle mounted antenna similar to what we've got here that we're using as an example. And what he noticed was he drove a small vehicle with a hatchback, and he did have to do the things that we did to get the SWR and the resonant frequency where it needed to be. But what he found was with the antenna mounted to his hatchback, he tended to get some directionality and likely some potential gain to the front of the vehicle. So he had his antenna mounted to the hatch, and what he found was the direction that he pointed the front of his vehicle, the antenna favored stations that direction. So that's something else that we can consider with our mobile mounts. The fact that you know, we may have to do some things to stop common mode currents, even on a vehicle, and also we may have to do some things to increase capacitive coupling, and as a result we could get potentially more gain based on where we place the antenna. So just food for thought there. I thought I would share this. I had wrestled with trying to get antennas to resonate where they should, particularly multi-band antennas for UHF and VHF. You know, I could get them to work fine if they were for a base station, but to try to get them to work on a vehicle, they tended to just float around until I found out that it was the common mode currents causing the problem. So to fix the common mode currents, you can use a ferrite core, or if you prefer, you could use ferrite beads. Just use 5, 7, 9 ferrite beads on the coax itself, whichever end works best for you, either the antenna end or the radio end, and that should take care of the problem, get you online. And again, look, we move the cable, we hold the ground, no change. The common mode current problem is fixed, and the capacitive coupling problem is improved. So anyway, hope this helps out somebody. If you like it, give it a thumbs up. If you think it'll help somebody else, share. If you haven't subscribed to the channel, consider subscribing, because we're always going to have things like this to try to help out the amateur operator. So anyway, until next time, take it easy. 73 and adios.